All right, time to put on our detective hats. Today, we're going to crack a case that's happening all around us, literally all the time. We're investigating the very stuff that makes up our world. We're talking about matter. So let's dive right in.
So every good investigation starts with a mystery, right? Here's ours. You've got an ice cube, and it melts into a puddle. Then you've got a log and a campfire, and it turns to ash. I mean, they're both changing, obviously, but there's a huge, fundamental difference between these two, and that's the mystery we're here to solve.
Okay, so our main subject here is matter. But what even is that? Well, the simple answer is, it's everything. I mean, everything. The chair you're sitting on, the air you're breathing right now, even this device you're watching on. If it takes up space and it has mass, boom, it's matter. It's basically the universe's ultimate building block. Any good detective will tell you the first step is always to gather clues. And in the world of matter, our clues are called properties. These are all the little unique characteristics that help us identify and describe any substance we come across. First up, let's talk about the most obvious clues, physical properties. Think of these as these surface-level details, the stuff you can spot just by looking or touching or measuring. The key thing here is you can observe these without actually changing the substance into something brand new. So here's our detective's toolkit of physical clues. You've got the really straightforward ones like color and size, but then there are others that need a closer look, like density. That's just how tightly packed the matter is. Or solubility, which is a fancy way of asking, will it dissolve in water? You know, like how salt just disappears in soup. Now, this is where it gets interesting. We can sort these clues into two main folders. On one side, we've got intensive properties. These are characteristics that stay the same no matter how much of the stuff you have. And on the other side, we have extensive properties, which, yep, you guessed it, absolutely depend on the amount. And this table breaks it down perfectly. Think about it. Water boils at 100 degrees Celsius, right? It doesn't matter if you have a tiny teacup or an entire ocean. That temperature is the same. That's an intensive property. But the mass, the volume, of course that's going to change depending on how much water you have. That makes it extensive. All right, we've got the surface clues down. Now it's time to dig a little deeper for the hidden clues. These are what we call chemical properties. And here's the thing, you can't just look at them. You can only discover them by seeing if the substance can actually change into something totally new. Yeah, see, these properties are all about a substance's potential to change. It's not about what it is right now, but what it could become. Flammability tells us if it has the potential to burn. Reactivity tells us what might happen if you mix it with something else. To find out for sure, you have to test it, and that test usually changes the substance for good. So, how do you tell the difference when you're on a case? I've got a super simple test for you. Just ask yourself this one question. Can I observe this without changing what the substance is? If you can say yes, it's a physical property. If the answer is no, well, then you're dealing with a chemical property. It's really that simple. Okay, detective. We've gathered our clues, our physical and chemical properties. Now for the exciting part, analyzing the evidence. This is where we look at what happens when matter actually changes. And this brings us right back to our original mystery with the ice cube and the log. So let's start with a physical change. This is any change in size, shape, or state of matter. We're talking about ripping a piece of paper, crushing a can, freezing water into ice. The substance might look totally different, but deep down, at the molecular level, it is still the exact same stuff. And here we are, back at our melting ice cube. It's going from a solid to a liquid, right? That's a change of state. But is it still water? You bet it is. It was H2O when it was a solid cube, and it's still H2O now that it's a liquid puddle. Same identity, just a different look. That is a textbook physical change. Now, a chemical change, that's a whole different beast. This is a real, true transformation. The original stuff is gone. Poof. And in its place, you've got one or more brand new substances with totally new properties. It's a point of no return. And that leads us to our burning log. The wood reacts with the oxygen in the air and is transformed into completely new things. Ash, carbon dioxide gas, water vapor. And there is no way to take that pile of ash and turn it back into wood. Its chemical identity has been changed forever. That's a chemical change. You know, there's another layer to this whole thing. Energy. It might sound a little weird, but for water to freeze into ice, an exothermic change, it actually has to release a little bit of heat. And the opposite is true for an endothermic change, like boiling water. It has to suck in a ton of heat energy from the stove to make that change happen. This flow of energy is another huge clue for us.
So the big question is, how can you be sure you're witnessing a chemical change out in the wild? Sometimes it's obvious, but other times it's pretty subtle. As matter detectives, we need to know the telltale signs. You know, the smoking guns that prove a chemical reaction has really happened. Well, here it is, your official detective's checklist. If you see a sudden color change, like an apple slice turning brown, or a new smell, like milk going sour, or maybe bubbles start forming when you mix two liquids. If a new solid, what scientists call a precipitate, just appears out of nowhere, or if you see light and heat being produced, like from a campfire, you can be pretty darn sure you've just seen a chemical change in action. Okay, you've got the skills, you've got the checklist. Let's solve one last case together. Boiling an egg. What do you think? Physical change or a chemical one? Let's look at the evidence. I mean, think about it. You start with a clear, goopy liquid and a runny yellow yolk. You add some heat and they become a solid white and a solid yolk with totally different textures. And there is absolutely no way to uncook that egg. A brand new substance has been created. Case closed. It's a chemical change.
And just like that, the case is closed. The big difference between melting ice and a burning log is whether or not the substance's core identity changes. So now that you're an official matter detective, keep your eyes open. What changes are you going to spot today? I mean, really look around. When you're cooking dinner, see a bike that's getting rusty. It's happening everywhere. The evidence is all around you.